Hello everyone. I will introduce the LLM-enhanced action-aware multi-modal prompt tuning for Imagitext matching. Imagitext matching aims to match images with the most relevant texts and vice versa. For example, given an image query, we find the best matched text from text dataset. For text to image, given a text query, we find the best matched image from image dataset. Recently, larger-scale pre-trained models such as CLIP have demonstrated superior generalization and transfer capabilities across various downstream tasks, making CLIP one of the most widely used pre-trained models for Imagine text matching. Recent studies have focused on improving object-level understanding by introducing learnable prompts that capture finer details of image regions such as objects or their attributes, thereby enabling CLIP to learn more fine-grained representations and enhancing its performance in detailed visual reasoning. Despite these impressive results, it remains unclear whether CLIP can effectively perceive actions, i.e., states or relationships between objects, in the context of Imagine text matching. For example, CLIP often fails to correctly retrieve the Topony matching text given an image query or the Topony image given a text query. Moreover, action-related mismatches constitute a relatively high proportion of these errors. These observations indicate that CLIP exhibits deficiencies in accurately perceiving actions, i.e. states or relationships between objects. To address this challenge, we propose to endow CLIP with fine-grained action level understanding by introducing an LLM-enhanced action-aware, multimodal prompt tuning method incorporating the action-related external knowledge generated by LLMs. Our method consists of two main components: an action knowledge generation module to extract and generate two kinds of knowledge, an action-aware adaptive interaction module integrate the knowledge prompts together with visual tokens to effectively capture various levels of visual information related to the action. Specifically, we design an action triplet prompt and an action state prompt to exploit compositional semantic knowledge and state-related causal knowledge implicitly stored in LLMs. Subsequently, we propose an adaptive interaction module to aggregate attentive visual features conditioned on action-aware prompted knowledge for establishing discriminative and action-aware visual representations, which further improves the performance. Now I will introduce the generation of action knowledge. First, knowledge exploit compositional semantic knowledge implicitly stored in LLMs. Action state exploit state-rated causal knowledge implicitly stored in LLMs. For action triplet encoder, to make action triplet prompts carry sufficient compositional semantics present in actions, we design an action-aware triplet encoder with transformer layers to explicitly model the action relations between paired objects. Specifically, we generate word embedding by employing a CLIP-based tokenizer and then concatenate these embeddings to form a unified representation for each triplet. Finally, we feed them into multiple transformer layers to generate action triplet embedding features. For frozen text encoder, we first define a prompt template and use a frozen text encoder to encode prompts into action state prompt embedding features. For prompt alphabet, we feed different types of action-aware prompts into prompted data to generate action-aware visual prompts. For action-aware adaptive interaction, we use cross-attention and self-attention to make the original patch feature attend to action triplet prompts and action state prompts, resulting in augmented image features, and these features are then transformed by MLP and a reweighting strategy. Afterward, we concatenate the learnable visual prompts and action-enhanced visual features, resulting in the final visual features. The output of the last layer is treated as the prompted image features used for optimizations. Now, I will introduce two-stage training. In this stage, the objective is to update newly added parameters of action-aware prompts, triplet encoder, and action-aware adaptive interaction module while keeping the original weights of CLIP frozen. In the second stage, only the parameters of the action-aware adaptive interaction module in visual encoder are upbized while keeping the action-aware prompts and prompt adapter frozen. The whole training process utilizes the action-aware prompts to mine and store the hidden states of the pre-trained image encoder, enabling CLIP to retain its advantages. The first stage focuses on learning effective prompts to fully harness the capabilities of CLIP, while the second stage refines multimodal interactions. We evaluate our method on COCO and Flickr 30K dataset. From Table 1, we can see compared to other clip-based methods, our method achieves competitive results on both innate ICE. From Table 2, we can see combination of two types of action prompts can improve matching, and removing either the action triplet prompt or the action state prompt leads to a drop in matching performance. From Table 3, we can see incorporating action, attribute knowledge enhances the fine-grained perception ability of the pre-trained model. From Table 4, we can, using different types and sizes of limbs, has little impact on performance, more results. Analyses are in the paper. We also visualize the comparison results between our method and clip. Given a text query or an image query, with the help of action knowledge from LLM, our method retrieves top 2 ranked results matching the query. Moreover, compared with WO action triplet, W action triplet retrieves images that depict the action of holding, which partially aligns with the intent of the query. Thank you for your attention.